So if we just look into the statistics side, I believe you have your scientific calculator with you, right? That's one thing, right? So we can look into the introduction of statistics. What is statistics, right? What is statistics? How do you define statistics? What is statistics, right? So you find that I'm sure some of you might not appreciate maths, but it's very important to appreciate this concept that we are doing, because you see it even when you are doing your data science course. So it's very, very important in your data science program. So statistics can just say it's the science of collecting, and you can analyze, and you can also interpret, you can also present, and you can organize data, right? And it involves some using mathematical techniques, that is to summarize and also describe data, as well as to, you can draw conclusions, and you can also make predictions based on that, right? So there are key aspects of statistics that you need to be aware of, right? So these key aspects of statistics that you should be aware of is we should be looking to collecting data, right? Then you analyze the data, so you can see what is data. Data is a raw fact, right? Then you should also analyze the data depending on the tool that is recommended, right? Then inference is just to infer, is just to come up with a conclusion. Then you can do presentation, that is communicating statistical results and findings through reports, graphs, and other visualizations. So basically, there are types of statistics that you need to know, right? So as you can see, there's these components of descriptive statistics that is stated there, right? That's one type. Then the second type of statistics is inferential statistics. Then the third type is exploratory data analysis, right? Then there's machine learning, right? So those are the types of statistics, but ours that we are going to delve much into is descriptive statistics. So when you talk of descriptive statistics, right? You are saying descriptive statistics. It's you can say it's summarizing. Okay, I wanted to allow Belinda in the class. So when you talk of descriptive statistics, right, it's summarizing and describing data, that is using measures such as mean, right? Mean doesn't mean selfish, right? It's average. Are we together? Right? Are you with me there? Hello, can you hear me? No, Emmanuel, you're on mute. Emmanuel, you're on mute.
Hello.
Yeah, you're on mute.
Hello.
Hello. Okay, so I was saying mean, it doesn't mean to be selfish, right? It
Okay.
just means yeah, it just means to the average, right? So then we also have got median, which is the middle value. Then the mode is the most common. Then we also got the standard deviation. So that one we can calculate it, the deviation from the mean. Then we also have got inferential statistics, like I said, where you can come up with a conclusion, right? Then exploratory data analysis, they is using visual, right, and quantitative methods to understand and summarize that. So you use visuals, that is where you can use pie charts, bar graph, dot plots, histograms, stem and leaf diagrams, then other diagrams, right? And but machine learning is when you are using Python. So in our case, we are not using Python, right? We are, it's just calculations. So you need to have a scientific calculator. Then sometimes you might wonder, like, where do you apply statistics? Because you said these things we do them, but where do we apply them? It's very important because you can use them in business, that is in market research, forecasting, right? You can also use them in medicine. You can also use them in social sciences. You can also use them in engineering. And you can also use them in sports, right? So I've spoken about common statistical concept, that is the mean, mode, median, right? And standard deviation, correlation. Then there's regression. There's also hypothesis testing, right? So in talk of hypothesis, so when you talk of hypothesis testing, you are looking into testing a hypothesis about a population based on sample, right? On sample data. So I know sometimes the other thing is, feel free to contact me on my WhatsApp on inbox, right? Whereby you express your level of understanding with regards to how far do you understand maths, right? Because sometimes we are not on the same level of understanding, right? We are on different levels. Then there are other software used in statistics. So there's R programming. You can also use that R. You hear about R. And there's also Python, that is the common one. Then there's SAS, right? Software. Then there's SPSS, statistical package software. Then there's Excel, right? So I would say that is the part of descriptive statistics. Then we define introduction to statistics, right? Then we can talk of sampling, right? Obviously, sampling, you're not saying you have a definite thing that you have, but sampling is just crucial. That is in terms of is a crucial aspect of statistical analysis, right? So sampling is the process of you select a subset of individuals, that is items, right? Then when you have got items, then you also have got data points, right? Right, from a larger data set or a population representation that represent the characteristic of population. Then why? So there are several reasons why we need to sample, right? There are several reasons why we need to sample. The other thing is we need to have cost and time efficiency. Then we need to have increased accuracy. Then we also need to improve generalization. Then there's also types of sampling methods, right? So the probability sampling, there's non-probability sampling, and there's also sampling techniques that you can also use, right? That is systematic sampling, 1, then 2, multi-stage sampling, 3, panel sampling. There's also sampling error, right? That you can also find sampling errors. So 1, we've got sampling bias, then we've got sampling variance, then we've got sample size determination, right? Okay. Then we need to look into introduction to time series, right? That's what I introduction to time series. So when you talk of time series, you're saying we have got the time as the determining factor, right? Are we together? So when time is the determining factor, so time series analysis is a statistical technique that is used to analyze and also to forecast data that is collected over time. So it involves identifying patterns, trends, and correlations in the data to make predictions about future values. So there are key concepts in time series analysis. That is the first one. You can talk of time series, you can talk of trend, then seasonality, you can talk of cycles, then you can talk of irregular variations. Then there's also stationarity, right? So there's types of time series analysis, right? That you can talk of, right? So there's types of time series analysis, that is descriptive time series analysis. Then there's also inferential time series analysis. Then there's exploratory time series analysis. So that is the time that we can look in. So briefly, that is what we can have. So we can say we have so we can just have chi-squared, right? The chi-square test that we can have, the chi-square contingence method, right? So I would say when you talk of contingence method, what are we talking about, right? So we are saying chi-square contingent analysis is a statistical analysis technique that is used to determine whether there is a significant association between two categorical variables, right? That is two categorical variables. So you're looking into assumptions of chi-square contingents, right? So there are a lot of assumptions that we work with. So you can look into independence, random sampling. You can also look into expected frequencies, right? That is what you can also look into, right? So basically that is what we can talk about in terms of statistics perspective, right? Then, so that is the statistics side in summary. Then if you look into, let's just go into database design concept, right? All right, so let's look in database design concept. I'll just zoom here. Right, so we have got introduction, objectives, database management system. But this one is very, very easy. You find it's very easy. It's very, very easy. The way they've set the objectives, you can't. Okay. Okay, DBMS, database management system. Right, so this one we start by database planning. So there are different databases that you can use, right? You can have MySQL Workbench, right? Microsoft Access. You can also have Microsoft. We talk of Microsoft SQL Server, right? So Microsoft SQL Server, we can download it. After downloading it, we can have an appreciation, right? Even if there is not prescribed in any case, right? We can be able to just appreciate how it works, right? So this is Microsoft SQL Server that I have downloaded, right? So I use SQL Server Management Studio. So database management software is a software that allows you to define, create, maintain, and also to manipulate databases. So it provides a way just to store, organize, and retrieve data efficient. So there are key features of database management software, right? That you can come across, right? There are key features. That is, you can look in data definition, data storage. Then you can look in data retrieval, data manipulation, data security, data backup, right? So actually, there are 4 types of databases. There's relational database. That's the one that we work with mainly. Then there's NoSQL database. Then there's object-oriented database. Then there's graph database management software. And then we can look into the components of the database management software. So there are so many components that we can play around with. That is database engine, query optimizer. We look at query executor, transaction manager, then also got storage manager. Then there are database management software languages, right? That is the SQL, NoSQL, then database specific languages. Like we've heard about Oracle database. So this is for Microsoft. So you can just go here and say new query. Then after saying new query, you can just say create, let's say create database. You can just name it. Let's look into your name. The Mambure. Then we execute, right? So it will say command completed successfully. And you can check here, right? Is Mambure there now? It has been created, right? So that's easier. So inside there, you can now create tables. You can create tables, column names, specifying the data types, right? Okay, so that is the database. So in all this that I've done, for you to come up with that, you need to have database planning, database design, the conceptual design. So the conceptual design, that is where you're drawing the ERD, the entity relationship diagram, right? So in the ERD, that is where you have a visual representation of an organization's data, showing the relationships between different entities. So an entity is the name of a thing, a place, or an item. Then you look into the attributes, the characteristics of the entity. Then the entity name now will become a table name. The attribute name will now become the column name, right? As you map from, because you start from conceptual design, then you map to logical design, then you map to physical design, right? That is what you work with, right? Are we together there? Okay, then under the key components of an entity relationship diagram, you need to understand what is an entity, right? That is represented by rectangles. You need to understand attributes represented by columns or fields. Then you also need to understand relationships that's represented by lines or arrows. Then you also need to understand cardinality, right? Then you've got types of relationships in an ARD. So you can have one-to-one relationship. Like now it's one-to-one relationship, teacher to student, right? One to many. If you were many, it was going to be one teacher to many students. But if it was many to many, it was going to be many teachers to many students, right? That is types of relationships in an ERD, right? So you also consider about the ERD notations and ERD symbols and notations, then steps to create an ERD, right? So then you also need to look into the software that you are going to be using. So you can also use Lucidchart, right? So Lucidchart is one of the softwares that can also be used. So Lucidchart, you can find it on the internet, right? That is, you log into the internet, then you check when you log in there. So this one is for free and it's not paid up, right? This one is Lucidchart. You can also use Microsoft Visual, right? Microsoft Visual, you can download it. It's for free. Then you can also use Draw.io, right? There are so many softwares that you can use. Okay, so that is the main thing that you need to know. Then implementation and downloading, testing and evaluation, those are just minor things. So what we have just discussed now, what I've just explained to you now, it touches on all these units, right? Like if you go to, that is unit 1, right? Then it goes to unit 2, right? ANSI Spark, it's just a data definition. That is what I've just explained now. Then database life cycle, then the entity relationship diagram, the ERD, right? Then you also need to look into enhanced entity relationship diagram. That is the class diagrams. Then you also need into so that is actually it touches on everything there, right? Right. So we have got that. Okay, let me just admit one person who wants to get in. I think there's Steven Maposa. Right, then we go to the enhanced entity relationship diagram. So we can have weak entities, right? So we have weak entities. So when we have weak entities, right, obviously when we have something that is weak, something that relies on the other, right? Like a weak entity. Then we go to entity integrity, referential integrity, we have the primary key and the foreign key, right? Whereby we say an entity, it connects, like, let's say a parent is the entity, then we have the child as the entity. So a child reference is the parent, right? So that is whereby we say, when we say the ID number of the parent cannot be used by the child. Now that ID number is the primary key to the parent. When it goes to the child, it's a foreign key, right? So because the child has to reference the parent, right? But we can't have a child end it when we don't have a parent end it, because that would mean that that child is orphaned, right? So that is so it also relates even to our everyday life. Then we go to the conceptual design. Like you go to the conceptual design. So when you go to the conceptual design, it takes the concept of our everyday life, right? Whereby we say the conceptual design, the way entities relate, right? That the entity relationship diagram. Then when you go to logical design, logic is just to reason well, right? Whereby when you say their reasoning, but well, so we are saying we are looking into the number of entity relationships, like one student to many to one lecturer, one lecturer to many students, or many lecturers to many students, right? Or you can have a recursive relationship, a relationship whereby say something depends on its own, like you, Emmanuel, or Stephen, you go into OK supermarket, you want to buy something. So the thing that happens is that the decision that you are making to buy some groceries there, it's your own independent decision, right? You're not influenced by anyone. It's a recursive relationship. Because you're a customer, an entity, or you're a manager, then that relationship that exists in yourself as the manager, because no one manages you, you manage people. It's a recursive relationship, right? So that one we've touched base on that. When you talk of abstraction, hiding implementation details from the user, all right? Then we go into normalization. So normalization, you are saying grouping related entities together, right? We have reasons why we need to normalize our data. We want to remove insertion anomaly, because we can't have same, like, let's say you go to where you collect your IDs, right? To the Home Affairs, Ministry of Home Affairs. You can't say you have duplicate ID numbers there. That won't be possible, right? So we need to normalize that, right? And put rows, like putting data in the same data types, right? The same columns. And then we have functional dependencies, where you say attribute A determines attribute B determines attribute C. Then there are 4 normal forms. First normal forms, where you remove repeating groups of data. Second normal form, where you remove partial dependence. Then third normal form, where you remove transitive dependence, right? Then finally, there's Boyce code normal form, right? Then the introduction to SQL. So what I just did there was just introduction to SQL there, this one, SQL statement. So we pronounce this as SQL, not SQL, SQL. Are we together? So we look into the history. Obviously, history is important, because the reason why we do history, even in our IT program, is because you go to work in Econet, you find that they've got systems that are a bit outdated than the one that you find in Telecel. Even if you go to Telecel, Econet, even if you go to Net1, they might be like you're using Office 2010 in Net1. When you go to sales to Econet, they're using Office 2019, right? So you need to know the history of these databases, right? So we can also just touch base on development from this stage. We have got Office, we've got Microsoft SQL Server 2019 now. We are moving to this now, and to this Microsoft SQL Server 2022, right? You find that 2019 might be doing some things that are not being done by the other, right? Then you go into the basic structure of SQL statements, right? So this is a SQL statement where I say the create database Mambure, right? It's a SQL statement, structured query language. Then what is the required output? What have you learned? What are the tables involved? How are tables linked? So tables are linked using a foreign key, right? Then we can go down, that is unit 10, right? Then we've got data definition language. So it still goes back to these Microsoft SQL Server. So you just need to download a stable internet. Then from there, you can work out your stuff. Then we've got data management, right? Or you can delete, insert commands. Those are SQL statements. Then we have got query data. So it's like select stuff from querying. You're asking the database, right? Asking the database. Yeah, so that is what you can have. Right, I don't know if you have any other concerns so far. I've been talking and talking and talking. I don't know if you have any issues on your side.
So far so good. I think we are going to have a good time.
Oh, okay, that's fine. I don't know on your side, Mambure, you're muted. Maybe you're afraid of your background noise. Okay, Mambure is muted still.
Listen.
Okay, that's fine. So we can go to unit 13. Then this one is so interesting. We still use the SQL statement. The fact that these things, they are also connected with Excel, right? Very close to Excel, even very close to SPSS, very close to Python. It's one and the same thing. Even ARA. Use this now search is not now, right? Now it means empty, right? Is now, right? You cannot leave the cell empty. Or when you deal with Excel, we talk of cells, right? So if you say is not now, you cannot leave it empty, right? Not now, right? Okay, so union, you still use those Venn diagrams that we were using when we were doing mathematics. But now you need to appreciate their practical application where you say aggregate function is a summary. If you talk of minimum, you're looking at the minimum mark, maybe for this database module for the student we have written in the maximum mark, right? And they're also looking into the average. You're looking into the number of participants, that is an aggregate, a summary. Right, then you look in database development. So you look at database development. So we have spoken about the primary key. We've spoken about referential integrity, foreign key. Then we can also look into, let's look into switchboards, right? That is the guidelines for report design. So report design is just a professional way of presenting your database, right? Information to the other users. Okay, so that's unit 15. So yeah, so that's an overview of the database, right? Then you go to data structures in the algorithms, right? Okay, so data structures and algorithms. We are saying each programming language has got its own data structures and algorithms, right? Be it Java, Python, C#, C++, right? But in data structures and algorithms, we are looking into arrays, right? So an array is just a collection of elements of the same data type stored in contiguous memory location. Then you talk of linked list, right? That is we talk of a dynamic collection of elements. That is where each element points to the next element. Then you talk of stacks. So stacks like you are piling books. So we can say a last in, first out data structure where elements are added and removed from the top. Then talk of queues. That is a first in, first out data structure where elements are added to the end and removed from the front. Then talk of trees. That is a hierarchical data structure where each node is a value and 0 or more child nodes. Then you talk of graphs. We say a non-linear data structure where nodes are connected by edges. Then you talk of hash tables, right? That is a data structure that maps keys to values using a hash function. So there are algorithms. So an algorithm is a set of steps that you can use to solve a problem. Like let's make tea, right? If you're making tea, the set of steps that you are going to follow and making tea is an algorithm. So you can have sorting algorithms, that is the bubble sort. Then so there are 5 types of algorithms: sorting algorithms, searching algorithms, graph algorithms, dynamic programming algorithms, grid algorithms. So under each, like if you talk of sorting algorithms, that is where we can talk of bubble sort, selection sort, insertion sort, merge sort, quick sort, right? Then also got searching algorithms, right? So this is where we have like linear search, binary search. Then we also talk of graph algorithms, that is the breadth first search, right? Depth first search, Dijkstra's algorithms. Then Dijkstra's algorithm is one of the one that you can find in operating systems, where you can use the Banker's algorithms. Then we have got Bellman-Ford algorithm. Then under dynamic programming algorithms, that is you can have Fibonacci series. So Fibonacci is you're adding. If you say is 0 plus 1, it's 1. So the next number will be 1 plus 1, then 2. The next number will be 1 plus 2, 3. Then 2 plus 3, 5. Then 3 plus 5, 8. Then 5 plus 8, 13. Then 8 plus 13, 21. That's Fibonacci. not the Fibonacci that you find in Prison Break, right? You know, Prison Break by Michael Scofield and Lincoln Barrows, where they acted about John Abruzzi possessing Fibonacci, not that one, right? Then that under dynamic programming algorithms, we've got longest common subsequences, right? Then we've got shortest path problems. Then we've got greedy algorithm, right? That is, we have got the Huffman coding, activity selection problem. Then we've got fractional knapsack problem. Then you can look into big O notation, right? So this one, big O notation, is one of the things that you need to look into when you're looking into algorithms, where you say is used to measure the time and space complexity of algorithms, right? Okay, then that's fine. Then we also need to look into common algorithmic techniques, that is divide and conquer. Then the other thing, it's the other common algorithm techniques is dynamic programming, grid algorithm, then backtracking, right? So look into real world applications of these algorithms. You can use them in web searches, right? Web search engines. Like you, when you keep on searching certain things, it will suggest for you things that are in line with what you are searching. Social media platforms, that is where you can apply it. E-commerce websites, then GPS navigation systems, right? That is where you can apply them. Find that they can also, so now you can break it down into linked lists. We've spoken about these text, we've spoken about this text. So this is just a summary after that. Okay, so far so good. Any questions or queries that you might need to know?
So far, I'm just waiting to dive deep into this. I'm already
Makosa is
interested.
saying some.
I can't wait to dive deep. Hello?
Hello. Hello.
Can you hear me?
I can.
Hello, Mr. Dube? And
Makosa, you were saying something? Can you please come again?
I was saying I'm already interested. Say, I can't wait to dive deep into these modules.
Okay, all right. Right, that's
For
fine.
now,
Okay.
I can't say I don't have questions or I have questions, but I'm sure when we dive in there, I will have a lot of questions.
Okay, that's fine. We'll answer them. That's all right. Okay. So that's data structures and algorithms. Then you go into introduction to software engineering. Right. In your understanding, what is an engineer? What do you understand? What is an engineer?
From a layman's point of view, somebody who maybe would design something.
Someone who designs something, right?
Yeah,
So when they are
layman's
designing,
point of view.
so when they are designing something, is they design, they build, and maintain structures, right? Machines,
Yes.
devices, systems, material. So we can know that they designed something from scratch, right?
Yes.
So in that space, we are looking into designing software. So there's software process models that we are looking into, right? So we look into software process models. So in that line, it means what are the steps that we do when you're looking at designing a software? We are not just designing software, we are not just coding. So there's types of software process models. You can use waterfall model, V model, spiral model, the agile. Agile is the one that is used mainly. Then there's rational unified process. So if I find that it's iterative, you might need to go back again after designing the software and solve the problem again. So there's a phase of software process model. So you need to do requirements gathering. Then you need to analyze. So you need to analyze the need for a system. You need to analyze why we need to improve it. So like if you look into banks, like we have got NetBank, right? So we have got NetBank. Then we have got the commercial banks that we have. We have CBZ Bank Limited, then Stanbic Bank Zimbabwe. We've got Standard Chartered Bank, right? Barclays Bank of Zimbabwe. Then we've got NetBank Zimbabwe. Then I just need to allow Sanyao over there. Then we also have got FBC Bank Limited. Then also have got ZB Bank, MBCA Bank, Stewart Bank, the one that is owned by Econet. Then I've got IDBZ, the development bank, right? Then we've got Zimbabwe Development Bank, Agriculture Development Bank, Bank of Zimbabwe. Then we've got merchant banks, that is Kingdom Bank Limited, Tetrad Investment Bank Limited. Then the building society, we've got ZBS, we've got NBS, then microfinance institutions like Micro King Finance, Gatebucks Finance, e-housing, post office, right? Specialized banks, then Zimpost. So these banks, steps that are used in developing software, it's not just banks, even the mobile communication companies, right? So the major player being Econet, maybe Tele7, Net1, they are still in the same class. Then there's also Africom. Yeah. Then we also have got this one, the subsidiary of ZESA. This one that was offering modems. Also have got an option that we can work with. Also into mobile, but sometimes it's there and sometimes not there. PowerTel is one of the subsidiaries, so it will also provide the mobile service. So the steps that you need to follow when you're designing a software, you need to program, you need to debug, you need to do software validation, you need to do software testing, right? So those are some of the things that we need to look into. Then 3, software prototyping. So prototyping, you're saying you design something, right, as a program, you give it to the end users, they test it, right? They tell you what you need to adjust, right? When you have adjusted it, you send it back and say, can you add this, remove this? That's prototyping. Then software project management. We need to document your software, like what we have right here on this PDF portable data format software. This software is documented. That's why you can find the help and these menus. These menus were documented. Someone didn't just come up and code them. Then you need to do write software requirements, right? Like now we can figure out if all goes well, work together, you might feel like we need this, right? So under software requirements, are looking at the functional requirements, the function that we need, like adding, division, if it's a calculator, right? But let's say other non-functional requirements, like for example, the things that depends on feelings, like you want to open an account, but you find that maybe you go to bank A, the ceiling is damaged, right? And also the manager is trying to make coffee, but the coffee maker is not working, right? We go to bank B, the ceiling is nice, the air conditioners, they are so comforting. The manager is making coffee and the coffee maker is working. Obviously, you go to bank B, right? But does that have to do with your money investment, or are you receiving money from the bank as the source of getting money from, like as a source of between you and where you're earning money from? It's not, those are non-functional requirements, just like the color of a car, right? Find that the color of a car, maybe as a gentleman, you see a pink color, right? and the lady sees a pink color, right? The color of the car is not the function of the car, right? But you feel like maybe in terms of gender, it's more suitable for someone to drive a pink car if it's a lady. If it's a man, maybe you can talk of black cars, even tint, right? A tint, you say men can put tint on their car, but ladies, we just associate them something that is not hidden, right? So just that is non-functional requirements. But just to functional requirements, we're saying functional is your car. Can you be able to engage the gears? Can you be able to turn left, right? Does it have that power to drive speed, right? That is what you need to look into. Then we look into the other thing is user interface. Obviously, the user interface, they are done even Microsoft Word. You can design the login, the username and password is done. Okay, cool. Then okay, cancel, right? Username and password failed to log in, right? What is going to be the message? You write those messages before doing the actual coding of the system. When you code, you know I'm coding this thing. It should look like this. Not a scenario whereby when you start coding, you drag your interfaces. But that's not how you want things to be like. Okay, so that is unit 7. Then you go to unit 8 and 9, verification and validation. So validation, in short, you can say, let's say you want to write a birth certificate for someone. You can't write a birth certificate for someone who's going to be born on 6 December, like today, 1 December, right? You write birth certificate maybe based on 1 December, going back to what? To the previous dates, right? Same applies with, let's say, death certificate. You can't write a death certificate. You can write it for today or going backwards when the date someone was died, right? But if it's a booking for tickets, you can book today for the ticket, maybe to fly to Dubai, or tomorrow, or next week, or so forth. That's validation. So meaning your system should be able to be validated in terms of the dates, right? That is precisely validation. Then when you look into other things, whereby say this step should only accept numbers only, not a system whereby it accepts what do you call it, alphanumeric. It should be numbers only, or 10 digits if it's a phone number option where you're typing on a text box. Then when you do software testing, there are quite a number of things that you need to look into when you're doing software testing, right? You look into the functioning of the system, right? Then in that, you need to do unit testing, you need to do integration testing. Can they be joined together? You need to look into system testing, you need to look into acceptance testing, then also regression testing. So there are testing techniques that you can use. That is black box testing. You can look into white box testing, gray box testing, then equivalence partitioning, then boundary value analysis. Those are some of the things that you can use. So that is unit 10, right? Then when you go to unit 11 and 12, unit 11 you can look into process analysis and modeling. So to model is just to look into to model is, we say, an abstract representation of the real world thing or object, right? Right. So those are some of the things that we say. What do we have when we are talking of a model? So you need to model before the actual thing, whereby you say when you need to go to the ATM, what is happening on the ATM? You can model an ATM. In ATM, it has got a menu, right? Do you want to withdraw money? Do you want to deposit the money? Do you want to inquire the balance, right? So you need to model that in all the processes that happens on an ATM. They can be modeled on paper. Then when you go to the actual system, you need to code it, the system of the ATM. When you code it, you also need to figure out that we need physical ATM for someone to go. We need a camera to see whoever comes to the. We need whoever comes to the ATM. Then also we got Six Sigma for software engineering. That Six Sigma is a data-driven approach to quality management that aims to reduce defects and variations in processes. So it uses statistical tools and techniques to measure and improve the quality of processes. So I remember there's a bank whereby they wrote an examination for Six Sigma. 10 people all failed, right? So the Six Sigma methodology for software modeling involves the following phase. That is, you define, you measure, you analyze, you improve, you control, right? So these things, when you look at it like software engineering, you might take it for granted, like it's just a theory module. But let's connect it with all this banking system, right? And see the process that happens in there. Let's connect it with the mobile communication companies, right? Econet, Telecel, Net1, Powertel, and of thinking capacity of any mobile communication company, any insurance company, medical companies that are there in Zimbabwe. So you find that when you look into things, when they give you like a task to do something that is in line with this process, Six Sigma or process analysis and modeling, you find that you can barely answer anything in there. But you would say we have done this and it's so easy as just a module walk in the park, right? I've come across a situation like that whereby you see like we are given an actual task from the bank. So we need to familiarize ourselves with these technologies. So you've got ISO 9000, that is a family of international standards for quality management systems. So it just provides a framework for organization to ensure that their products or services they meet customer and regulatory requirements. So we've got the history of ISO. So history we look into when it started 1987, right? That's when it started. Then we also need to look into software changes. So the software they keep on changing, just like Windows, right? Windows it changed from Windows 98. I started using Windows when it was Windows 95. Then it moved to Windows 98, Windows 2000, Windows Millennium. Then we had Windows XP Suspect 1, Windows XP Suspect 2. Then we had Windows XP Suspect 3, Windows XP Suspect 4. They had Windows Vista, then Windows 8.1, 8.0, 8.1, Windows 7. From Windows 7, we moved on to Windows 8.1. We moved on to Windows 10, now Windows 11. Then there's also Linux. There are different versions of Linux that are there. So you just need to be familiar with what is Linux, what is happening. So if you don't know
No.
All right, so we can also have online simulator for Linux, right? So if you type, it will populate for you. All right, so I think that's all from my side for today. That's the general course overview of our program.
Okay. Thank you so much. So inini hangu I'm willing to start mangwana chaiwo. So tichaona kuti vamwe vachaita sei. Asi handizivi kuti kana kuri kuti vamwe vangu havana kuripa manje, handizivi kuti toita sei. Tongovamirira here kana kuti tosanofamba nevaripo.
Because the breakdown that I had done was the more the numbers, the less the charge, right, or the fee.
Okay.
So that's we had the breakdown where I said we do Monday to Friday, Monday to Thursday, 7 p.m. to 8 p.m. One day per module, 1 hour. Then if it's 10 students and above, you can pay $20. That makes it for the whole month, right? 64 4 hours for the module, 4 hours per module. But if it's 6 to 9 students, it's $25. If it's 1 to 5, it's $30. So that is what we have. Then there was the thing that
Network. Waona ili tuta wedu. Tuta wedu. Hello.
And how are you? Manuel? Hello?
Nah, network is not favoring us here.